There we go. Okay, so these are the major pieces that I want to emphasize today. I'll talk about some other things as well. This is available for more than 20 languages. SonarSou supports about 20 languages. Additional language analyzers are available from the community, but these are the languages that we support directly. At the heart of the Sonar ecosystem is static analysis. So before I dive into the pieces that I said I would emphasize, I need to talk a little bit about static analysis to make sure you guys understand what it is, what the benefits are, and why you would use it. So first, static analysis is a way of looking at your code to find bad patterns without the need to actually run it. So you don't need to stand up a second system to run your analysis against. You just feed in your source code, and depending on the language, your bytecode, and we take it from there. We use static analysis to find bugs, what we call code smells or maintainability issues, and some security vulnerabilities. We can't find them all. If you've got a separate security scanner, you should continue using that. But these are the things we use static analysis to find in your source code. And the reasons to use static analysis are manifold, but I'll limit myself to a few. First of all, I think probably everyone in this room is familiar with the statistics about what it costs to fix a problem when it's found late in the process versus when it's found early in the process. Using static analysis, there are some of the dumb things that we can catch very early. Now, let me be clear to say that we can't figure out that you did the wrong thing, but we can figure out that you did something in a wrong way, right? So if it was supposed to be blue and you made it purple, we can't figure that out. We can't read the requirements. But if you've made some other kinds of mistakes, we can find out with static analysis. Now, if you talk to developers, some developers, probably no one in this room has dealt with developer ego, right? Will say, well, I write good code. Well, probably most of the time, yes. But all developers are human. All humans make mistakes. So we still want that backstop, right? And in SonarSou, when we raise an issue in code, we're going to give you two things that really help you understand what the problem is and what you need to do to fix it. First of all, we're going to give you a precise issue location. So not this screen of the application, not this file of code, but these characters in this line, the problem is right here, and here's a description of the rule you've broken that tells you why it's a good thing to follow the rule, what bad things can happen if you break the rule, and some code examples to help you understand what bad code looks like and what fixed code looks like. Other reasons are unintended consequences. Internally at SonarSou, we use a pull request peer review cycle. So no code change goes into production without being looked at by at least one more pair of eyes, right? So if I submit a PR, someone else is going to review it, and then it gets merged into master. But if my PR makes a change to file A, and my PR doesn't touch file B is not going to be included in what my peer looks at during that peer review. And if my change to file A has introduced a problem in file B, that's not going to be caught in peer review. But a static analyzer is going to look at every file every time. It never gets tired, it never gets bored. So it can find that unintended change in file B. And finally, static analysis can provide a little coaching. So during peer review, if I look you in the eye and say, this is bad code for this reason, depending on how I say that, egos could get involved, right? But if you're using static analysis to catch some of the simple stuff, then it's really hard for egos to get ramped up when you've basically got a robot telling you there is a problem here. And so static analysis can help when you've got a developer who's maybe new to the industry or maybe changing languages, new to the language and doesn't know the language best practices, or maybe new to the team and doesn't know the coding standards that the team has agreed to. So that's another reason to use static analysis. Now, those are reasons you might want to involve static analysis in your process, other than the fact it's totally fabulous. So I'm going to talk a little bit about how it works and what it can catch. The first stage in static analysis is what's called lexical analysis. So it's when you take the string of characters, whatever that string is, and you break it up into tokens. So for this quote, the example is where we figure out where the word tokens are. The next step is syntactic analysis, where you start to understand what kinds of tokens we're dealing with. So you find the subjects, you find the verbs, you find the objects, the articles, etc. After that, you get into semantic analysis, which is where you begin to understand how the symbols relate to each other. So semantic analysis is where you understand that two things refers to the universe and human stupidity, and that the former refers to the universe. Beyond that, you get into symbolic execution. So as a peer reviewer, as a coder, it doesn't necessarily jump out to me that there's a null pointer dereference in this snippet of code, but there is. So I'm going to walk you quickly through how a static analyzer understands that there's a null pointer dereference in this code. And we do that by looking at program states. So after we execute the first line of code, we're at program state 0, where we know for sure that there's a variable named myObject and its value is not null. Okay? After that, we come to this first if statement. And after the if statement, we have two possible states. There's state 1, where A was false. We didn't enter into the if, and myObject is still not null. There's state 2, where A was true. We did enter into the if block, and myObject is now null. Right? Now we're looking for the path where we get to the null pointer exception. So at this point, I'm going to ignore state 1 and focus on state 2. In state 2, we know that A was true and that myObject is null. So since A was true in state 2, we know we're not going to go into this next if statement, right? Instead, we're going to fall through to the else with the null myObject. And, oh look, we dereferenced myObject. Let's raise an issue here to tell the programmer that there's a potential null pointer dereference so he can come and fix this before the users find it or before the testers find it. Beyond that, you get into cross-procedural analysis, where you start following the values from method call to method call to method call, so that if you set it to null here, but you dereference it in a different method, we can still detect that. So earlier when I said that static analysis is analyzing code without actually executing it, that's literally true. But figuratively, we are symbolically executing it by following all the different paths to understand what the potential outcomes are. Symbolic execution is available in most of our mainstream analyzers. So SonarSou Sharp, SonarSou Family, SonarJava, SonarJS, excuse me. And that allows us to find things like null pointer dereferences, even in JavaScript. It's not called that, but it's very similar in JavaScript. Unconditionally true or false subconditions. So that's something that the programmer thought was going to happen conditionally, but maybe always happens or never happens. We can also find division by 0, which is a fall down and go boom kind of problem in a program. And we can find resource leaks, which is a slow death kind of problem in a program. And probably difficult to find unless you're doing load testing. And in C++, we can find double free. So I don't want to bore you for 45 whole minutes with slides. I'm going to jump into my IDE now and show you SonarLint, because I promised you from the first keystroke. So I'm going to do some keystroking here. All right, so this is IntelliJ's idea, and I've installed in it SonarLint, which is a free plugin that bundles most of our mainstream free and open source code analyzers. Not all of our analyzers are free, but it does bundle in the free ones. And so they're going to run as you type to check the code that you're typing. So I'm going to do some typing here. Sorry, my hands keep hitting the trackpad. All right, and so this takes a second sometimes, but very quickly, an analysis is run on my now typed code. And down here at the bottom in the SonarLint tab, it's telling me that I have some new issues on this code that I've just typed. Now, if I don't have the SonarLints tab open, I might notice these dark yellow highlights, and I can mouse over them to get an instruction about what to do to fix the issue. So it doesn't like my empty code block here, my pair of curly braces. It doesn't like that I'm using system.out. It tells me I should be using a logger instead. And here it's saying, oh look, you could have the null pointer exception here. Now, down here I've got a list of all of the issues in the file. If I had opened the file with existing issues, those would be listed here as well. And if this were scrolled off the screen, I could go to it by clicking on the issue in the list. The other thing that does, clicking on the issue in the list, is over here on the right, brings up the rule description. So if I've got any questions about, for instance, why system.out shouldn't be used or why I shouldn't have an empty code block, the rule description should explain that to me. And not all issues have secondary locations, but the more complicated to understand ones do, such as null pointer dereferences. So it also gives me access to the list of additional locations for issues that have them. Now notice when I click on this issue in the list, it lit up in blue 2 different points in my code. And if I click here, it's telling me that this first location implies that foo can be null. As a programmer, I have the feeling that foo could be null, or I wouldn't have null tested it here. But then I unconditionally dereference it. So I probably got a problem here. Either I can get rid of the null test, or I need to do an additional null test. Or maybe what I really meant to do is this. And if you notice, my other 2 issues went away pretty quickly. All right? But let's say that for whatever reason, I didn't have my SonarLint pane open, and I was too focused on my code to notice those dark yellow highlights, and so I'm just going to plow forward and commit this. And commit. Now, by default, a pre-commit analysis is going to kick in. So at this point, I can ignore the issues if I want and commit anyway, or I can go back and review the issues. That takes me back into the SonarLint tab, and it takes me to the Project Files tab. So by default, I'm looking at issues in the current file. That's this tab here. Or I can go to Project Files tab, and I've got 2 choices here. I can look at all of the files. So I can run a local analysis of all the files in the project. We don't recommend that, because if you've got a moderate to large project, and that can be time to go get coffee and chat with your friends. Or I can be looking at all of the files in my change set. So that's everything that's been changed. And now it's going to tell me, hey, you've got this issue. Do you really want to check in this code? All right, but let's say that I've disabled that, or I just haven't installed SonarLint because I write good code. All right. Fortunately, you have integrated full analysis into your CI chain, right? So the way this works at SonarSource is I write code in a branch, I submit a pull request, it's peer reviewed, and peer review is looking for structural things. It's not looking for things like, oh, you have an empty code, it's not looking for things that the static analysis is going to find anyway. So I pass peer review, it gets merged into master, and as soon as it gets merged into master, then the CI system kicks in, right? So it's going to do a full build, and then it's going to do a full analysis, and then it's going to do the other things that it does. Now, when it does the full analysis, it's going to update the project in SonarCube. This is what a project looks like in SonarCube. This is a project home page. I've got a few things going on here. give you a brief overview. If you remember, this wasn't one of my main topics, so I'm not going to linger here. But here on the project front page, we're looking at overall values. On the left, on the white background, we've got overall values. So in this project, I've got 2 bugs. I've got 4 code smells. I've got 68.1% code coverage. Now, I was talking about issues earlier, so you probably are curious about the issues. I could click through on any of these issue-related numbers to get to a filtered list of issues, or I can just click here to get a list of all of the open issues in the project. I can navigate this with mouse or keyboard to go up or down the list, but more importantly, I can click on an issue or right arrow to see the issue in the context of the code. So it's not just a list of issues, it's a list of issues, and here's where you go to fix it, and here's some advice about fixing it. Okay. Now, I talked earlier about null pointer exceptions, and I wanted to show you an issue with secondary locations, because when we walked through that code example earlier, we were able to understand that there was going to be a null pointer exception because we walked through those program states, right? And it takes the static analyzer all those pieces of code to understand that there can be a null pointer exception. The developer is not going to understand it without that same context. And so we try very hard to give developers the context they need to understand the issues in the code. And so that's what we're looking at here on the left, is this little list of code of locations. So the issue is being raised here on the code with the red underline. But if I want to navigate the secondary, look at that. I want to navigate the secondary locations. I start with number 1 here, and it says visit terminal could return null. Okay, and that was in visit, and so visit could return null, and the result of visit is assigned to AST node, and then AST node is dereferenced. All right, so this is what we give the developer to help them understand why there's a problem and what they need to do to fix it. So, now I'm going to bore you with more slides. This is the cycle that I just showed you guys. So we start at the bottom here with Happy Coder, who's using SonarLint in his IDE. And SonarLint is available for IntelliJ's IDEA, Eclipse, VS Code, Visual Studio, and Atom. So most of the major IDEs SonarLint is available for comes prepackaged with the free analyzers, so you can just immediately start using it, whether or not you're also using SonarCube in your organization. But hopefully you are, and so you need to get it integrated into the build. You can do that pretty much however you're building your code. So there are integrations available for Jenkins, TeamCity, Bamboo, Travis, VSTS, and then the non-CI builds. So you've got Maven, Gradle, and NPM. There's also MS Build. I couldn't find a logo for MS Build. And if all else fails, there's a command line version of Sonar Scanner. So whatever other system you're using, you can just use that. Okay, so you run your full analysis. It's going to update the project in SonarCube. So you've got one central place for all of the stakeholders of your application to go to understand what the quality is on any given day of the project in its current state. Now, this diagram leaves out one piece. I haven't shown you this piece yet, and that's the integration between SonarCube and SonarLint. So I'm going to show you how that works, because here's the way it works. When we build an analyzer, we implement a lot of rules, but not all of those rules are applicable to everyone all the time. That's a much smaller set of rules. So when we craft the default rule set, the rule set that runs by default when you first spin up SonarCube, we work very hard to make sure that that rule set is narrowed to rules that are going to be good for 95% of people in 95% of the cases. But of course, everyone's exception, right? Maybe you want some of these rules because you're using this framework. And maybe you're writing a console application, and so you do want to use system.out instead of a logger, and so there might be 1 or 2 rules you want to exclude from the default rule set. So on the SonarCube side, you craft the rule set that fits your project, your application. Now, we don't recommend you do this on an application-by-application basis. Generally, you want to have the same set of rules applied across the entire organization. But most people do craft their rule sets a little bit. Okay, but in SonarLint, by default, I'm running the default rule set. So as a developer, I've got sort of a quandary here because I've got a different set of issues being raised in the IDE than are being raised in SonarSou. So that's why we have what we call connected mode. So to turn on connected mode, I'm going to enable binding to a remote SonarSou server, and then I pick my server. Now, if this were a fresh install, I would have to configure the server, but this is my day-to-day IDE when I get to code. So I've already set up the servers. And so I pick my server from the list. That pulls in the list of all the projects on that server. And, come on, scroll. There we go. So then I find my project in the list. And this is, I'm setting it on blind. Here we go. And I select my project. And it takes a minute. And you may or may not have noticed it, but there was a brief progress bar down at the bottom right. 3 things were happening when that progress bar was running. First of all, the rule set was being synchronized. So that now the issues that I'm seeing raised in the IDE correlate to the ones that I'm seeing raised in SonarSou. So that mismatch goes away. But the next thing that's happening is that the most recent version of the analyzer is being pulled down from the server. So let's say that I installed SonarLint 6 months ago. Well, Sonar Java has been released 3 times since then, and your SonarCube admin has upgraded it. And when you get a new version of an analyzer, you might get new rules. Almost every single release of every analyzer includes new rules that you may or may not want added to your rule set. The other thing that happens is that rules get smarter. So we eliminate false positives, we eliminate false negatives, the underlying mechanisms get improved so that sets of rules in general get smarter. And so that would be another source of mismatch between the issues that were being raised in the IDE versus in SonarCube. So you want to pull down that latest version of the analyzer, which happens when you sync like this, so that, again, that synchronizes your issue sets. The third thing that happens is that if I've got an issue that I've marked either false positive or won't fix on the server, I don't want to keep seeing that in my IDE, so we pull down those sets of issues, and so I never have to see those issues in either place again. So that's what happens when you synchronize. Just by the way, you may have to refresh your synchronization every once in a while just to force it to pull down new rule sets. Eventually that'll happen automatically. We'll work on that. Okay, so that was SonarLint. That was what I wanted to talk to you about SonarLint. Now let's talk about the leak period. The sad fact is that the first time you run static analysis on any project that's more than about 2 weeks old, the amount of technical debt you see as a result can be really depressing. The typical reaction is just kind of like, can we just turn this off? Because the fact is that it's very difficult to get a budget, permission to fix those things. So why should we be looking at them if we can't fix them, right? It's not a lot of fun to be told you have all of these old problems and know that you can't do anything about them. Plus, the users aren't complaining about them, and if you did start fixing them or you're introducing regressions, then you got to get that into the testing schedule. And so that's where the water leak metaphor comes in. All right? This is a go forth and sin no more kind of thing. All right? So the theory here is that if you walked into your kitchen tonight and you saw a puddle of water on the floor that was slowly growing as you watched, would you run for the mop? Or would you try to find where the water's coming from? Most of us are going to try and find out where the water's coming from and shut that off, right? And that's how it works with the water leak metaphor. The idea here is that those old issues are tested by time, right? They may be problems, but we're just going to set that aside right now, and we're going to focus on the code that's being changed today. Google says that it turns over 50% of its code base every year. The industry average is that 20% of your code base is changed every year. And when I say changed, I mean either new code added or old code modified, right? So I'm not saying that you're going to touch all of your code in 5 years, because you're not going to change a different 20% every year. But let's say in 8 or 10 years, you will have touched everything. And if, while you're doing that touching, you make sure that the code I touch today is perfectly clean, then at the end of some period, you will have a clean code base, right? So that's where we get to the water leak metaphor, what we're calling clean as you code. We've engineered the homepage to help you focus on this. So I said, we looked earlier at the project homepage. I want to look now, focus on the yellow part on the right. So on the left, we have overall values. For this application, I have 8 open bugs. And because of that yellow C, hope you guys can see that, next to that 8, I know that the severity of the worst open issue is a major. I've got 0 vulnerabilities. I've got 2.5 thousand open code smells. Now, code smell is a maintainability issue. This is not something is wrong. This is developers are going to have problems when they go to maintain this code, right? So this is a speed bump in the road to development, okay? But on the right, in the yellow portion, I've got 5 open bugs, and those are the ones I care about. These are the ones that I have to fix before the next production release. Now, what we recommend for what we call the leak period is since previous production release. Some people set it on other criteria, but what we recommend is since the last production release. So I released 6.5 2 months ago, and in that 2 months since the last production release, has the code that I've added day by day been clean? That's what I care about now. What I want to make sure is that I'm not adding any new problems to the code base in the next production release. So we're focused here on, we've got 5 new bugs to clean up before the next release. I've got 0 new vulnerabilities. That's good. For this second row here, we've got 25 days of estimated remediation time or technical debt on 687 new code smells. Now, that row gets a green A because the model works a little bit differently. For bugs and vulnerabilities, we're concerned about the severity of the worst issue, right? But because those are things that are wrong today. But maintainability, that's about future maintenance. And so for that rating, we scale it differently. For that rating, we look at the estimated remediation cost versus the size of the code base as a whole. And if that ratio is at a healthy level, then we say, okay, you've got an A, you can move on, even though you've got some open code smells. We've got 83.6% coverage, 0 duplications. So let's see, what do I have to do to release this? I probably need to fix my 5 bugs and then I'm good, right? So that's the leak period. That's how it works. That's what it looks like in the homepage and how you can keep focused on that. Next, I'm going to talk about quality gate, because right now, without the quality gate, we're sort of mentally doing the work every single time to check every single metric to make sure that it's in the parameters that we've set out, and that can be tedious and error-prone, right? So we've added the quality gate. The quality gate is a series of Boolean conditions that you set to let you know when your code is releasable by your standards. What we're looking at right now is the default quality gate. This ships with SonarSou. So if you spin up a new instance, this is what will be applied out of the box. But SonarSou Administrator has the ability to alter this or to set multiple quality gates so different projects have different quality gates. And again, we don't recommend that. We recommend that everyone play by the same rules, but that's not always politically feasible. So there is the ability to have multiple quality gates and apply different gates to different projects. By default, what we recommend is that you have at least 80% test coverage on new code, that you have ratings for maintainability, reliability, security of A, And I think we've added another condition to the quality gate, which is duplication below 3%. That's what we recommend by default. Here is what it looks like when you're failing the quality gate. We put this red fail lozenge at the top left of the page because that's where your eye falls when you first open the page, is the top left. And if you're failing, we tell you why you're failing. So your value is at X and it was supposed to be at Y. Now, on this previous page, I showed you coverage on new code is required to be 80%. And here's a project failing with 83.6%. That's because we've tweaked this quality gate. Internally, we require a higher standard. So internally, we require 85%, and that's why this project with 83.6% is failing the quality gate. It's also failing the quality gate because of those 5 new bugs that we talked about, because we require a rating of A. Okay? Now, there are 2 other potential states that your quality gate can be in. This is what it looks like when you're in those states. So if you're passing your quality gate, you get a green, all clear, go on with your day. And it's also possible to add warning conditions to a quality gate so that you can have this danger period that's still passing. And this is what it looks like when you're in that state. So that's the quality gate. And that was most of what I wanted to tell you about. Are there any questions? Yes, sir. So the question is, the integration between SonarQube and SonarLint, does it make the distinction between old issues and new issues? The answer is no, it doesn't. That would be cool. Yes. Okay. I'm sorry, start that again. Okay, so we do have pull request analysis for GitHub and GitLab. There are plugins to set that up. I didn't talk about those today because they're deprecated. But mainly, you're not going to integrate this. So the question was about integration to automatically fire off analysis with change in various SCMs. And we don't really do that sort of integration. What we really do is depend on the CI system to notice that there's been a change, and for the CI system to fire off the build and then the analysis. Because, for instance, in Java, you need to feed in the bytecode. We're reading both the source code and the bytecode for Java, something very similar for C#. And so we need a fresh build. We can't just pull out a Git and analyze. We need your CI system to notice the change and kick off the build and the analysis. Yes, sir. Yeah. It will be deprecated when 6.7 is released next month.
I mean, what
Yes. So with 6.7 LTS, we'll be releasing new commercial features that will work even better. But the fact is that the pull request analysis uses a deprecated, well, it uses an analysis parameter that we've been trying to sort of kick the curb for about 3 years now. And because we're introducing these new commercial features, and we've been trying to get rid of the analysis mode parameter forever, this just seemed like the best way to do all of that at once. Sorry. Yes, ma'am. Okay, so what's the difference between the static analysis that comes with IntelliJ and Sonar Lens? So you're going to see some overlap in the rules. In fact, to be perfectly honest, I turned off the IntelliJ analysis for this demo so that we didn't get confused about which warnings were coming from which analyzer. But in general, you're going to have a far broader array of rules that are available from SonarSou. And also, when you use the Sonar ecosystem, then all of the stakeholders in your system can see what's going on in the code versus only the developer in the IDE seeing what's going on in the code if he decided to leave it turned on, if he pays attention, etc. Okay, so there was a story that I forgot to tell you, and I think I've still got time to tell you this during my presentation, so I'll tell it now because I think we've run out of questions. And it's about the leak period. At a previous job, I did maintenance on a legacy application, occasional maintenance. And one day I got the fire, and I was going to add unit tests because this application had 0 unit tests, right? So I'm going to sit down and I'm going to add unit tests to this application because it's what you're supposed to do. And okay, so I'm going to do that method. Take my method, I sit down and do it, and I start scrolling. And this method is probably 800 lines long. Like, okay, I'm going to start at the top. And it took me about a day to realize that this method was just not testable. And I threw up my hands and I said, this can't be done. And I walked away in disgust and I said, unit tests are crap. This is where the leak period comes in. Because what happened was this thing that I talked about when you run static analysis for the first time, and you see this mountain of debt, and you go, oh my God, I can never scale this. Scaling quality. And if I had been using the leak period, I could have been very proud of the fact that each time I made a change in that application, I wrote one tiny testable method and I unit tested it. And I wouldn't care about the fact that the overall application had 0.03% unit test coverage. I would have bragged about the fact that my coverage on new code was 95%. Right? This is the benefit of the leak period. The benefit of the leak period is that it doesn't matter how bad your code is. It doesn't matter what the other guys did. It matters that today I'm doing a good job and I can point to it and everybody knows it. And that's all I've got. Thanks for your time. Oh, wait, one more question. Okay. We can talk about that later. All right. Thanks, guys.